Now we are going to do example number 7. I'm a little bit tired, it's midnight, so if I say something wrong, sorry about that. Now, this example says that, example number 7, if you don't see you by the light, I have new lights on the, not floor, on the ceiling, so it kind of reflects with this whiteboard. But it says that a square wave voltage of amplitude E equals 100 volts and frequency of 60 Hz. So square wave voltage of amplitude E equals 100 volts and frequency 60 Hz is applied on a coil wound on a closed iron core. The coil has 500 turns and the cross-sectional area of the core is 0.001 meter squared. Assume that the coil has no resistance. By A, find the maximum value of the flux and sketch the waveform of voltage and flux as function of time. By B, find the maximum value of E if the maximum flux density is not to exceed 1,2 Teslas. Now, if you don't have, if you can't imagine a magnetic circuit, you know, let's say it looks something like this. You know, here we have flux, goes like this, plus minus E, current I, and you know, this is, it doesn't say what kind of circuit or magnetic circuit it is, it just says it's a closed loop. So, first of all, let's assume that this circuit on the starting point is 0, so it was unmagnetized. So if we now in this point 0 there is no flux. Then in this point 0 we bring a square wave voltage that looks something like this. And it continues, it's a periodical waveform. Now it has amplitude 100 and minus 100 volts. Now, what is how the flux is going to change? Well, if you know that that E is equal the M dF by dt, this is the formula by Faraday's law. Now, in this term, okay, just a second. Now, if we have flux d. Now, here is how a flux is going to change. The integral of a square wave by the time is going to look something like this. It goes here. So this is how a flux is going to change in time. So this is flux. Now, it's something like this. In the 0 point here, it had a value of 0. So, and it goes here, it has flux max value, and here has minus flux max. But as you can see, this is not a steady state because in the beginning the flux has a transient process. So it's not a steady state. It's not something that repeats itself. We don't have a value 0 of flux where here and here. So this is not how do you say periodical waveform. The periodical waveform starts of the magnetic flux from here. As you can see, it goes here from flux minus flux maximum to plus flux maximum. So this from here to here, this is a half period from here to here, and the full period it goes here. So this is a full period here and here. So this here is not a steady state, and we're not gonna take the beginning. So we're gonna take a point where flux is equal to flux minus flux maximum, and the E starts from somewhere over here. So for the steady state, so this is very important to know that for a steady state, E is going something like this. And so on. So this is E, which has amplitude 100 volt and minus 100 volt. And just a second, let me take another marker. And the flux is going to start from minus so the blue line is flux, and the black one is voltage, which is a periodical square wave. Now, what is the period? Well, the period is equal to 1 divided by frequency, so it is equal to 1 divided by 60. So here we have 1 divided by 60. But here is a half period, so here we have 1 divided by 100 and 120. Here we have minus flux maximum, and here we have plus flux maximum. Now we have to calculate what is this flux maximum. Okay, it says find the maximum value of the flux and sketch the waveform of voltage and flux as a function of time. We sketched the waveform, but we don't know yet what is this flux maximum. Now let's go back in this formula. E equals n df by dt. Now E is equal to dt. E times dt is equal to n times the flux. But this is a small fraction of some waveforms. Let's take. What do we know about here? Well, we know that from here to here, from 0 to 1 divided by 120, that is delta time. That is some time past time. So we know that flux rises from minus flux maximum plus 2 flux maximum. But this flux maximum minus flux maximum, the length of this line from here to here is equal. Now if you look at it as a scalar, it is equal to flux maximum. So we are gonna say that E delta T is equal to n times 2 flux maximum. Now we are measuring not vectors but scalar in this half period. Now delta t is equal 1 divided by 120, and this E has a value of 100 volts in this half of period. So we're gonna say that E is equal to 100 volts, delta T is equal to 1 divided by 120, and we have n is equal to 500 turns, and we only have to calculate flux maximum. Flux max, looking from here, is equal to E delta T divided by number of turns, that is equal to 100 number of turns. This 1 divided by 120, 120 goes in the denominator here, so it's equal to 500 times 120, and that is equal to, oh sorry, I forgot this 2. This number 2 goes in the denominator over here, so we have 2 times 500 times 120, sorry about this, I forgot this number 2, and you get that the flux maximum is equal to 0.833 times 10 to the minus 3 Webers. Now, we know minus flux maximum is equal minus 0.8333, and flux maximum is plus 0.833 10 to the minus 3 Webers. So now this is the waveform, this is how it changes due time, and that is for A. Okay, now if you want to copy this in your copy this wherever you write these examples, you do it. I'm just gonna now B says find the maximum value of E if the maximum flux density is not to exceed 1,12 Tesla. Now we have that the B maximum is equal to 1,2 Teslas. Now, if you know what is the B maximum or the value of the flux density, we can calculate the flux. Flux is equal to B times A, which A is the area of the cross-sectional area of the core. So you get that the flux is equal to, sorry, this is flux maximum, equal to B max times A, okay? That is equal to 1.2 times 0.001. And that is equal to 1,2 times 10 to the minus 3 Webers. Looking at this equation, we can calculate the maximum voltage, and that is equal to N times 2 F max divided by the delta T. That is equal to 500 times 2 times this flux maximum divided by 100 divided by 120, and you get that E is equal to 144 volts. So this is the maximum value of the voltage. If we want to have if this is the maximum voltage that we can have, so that we won't exceed this value. Okay, so that's for this example. Thanks for watching and see you in my next tutorial. I'm going to show you what is the exciting current in the magnetic circuit. Thanks and have see you in the next video.